The Young's double slit experiment, angular width of fringes, angular width theta is equal to 0.20 degree. For sodium light of wavelength lambda is equal to 5890 angstrom. 5890 angstrom. If the complete system is deep in a water, complete system is deep in a water, angular width of fringes will be angular width of fringes theta in water, angular width in water, that we have to find out, and we were given refractive index of water is equal to 4 by 3. Refractive index of water is equal to what? 4 by 3. Remember, angular width in Young's double slit experiment, we know angular width theta is equal to lambda divided by d. Lambda divided by d, it means angular width theta is directly proportional to wavelength. Directly proportional to what? Wavelength. Therefore, theta in water upon theta in air actually is equal to wavelength in water upon wavelength in air, that is given. So, therefore, theta in water is equal to, that is angular width in water is equal to angular width in air into wavelength in water upon wavelength in air. Wavelength in water upon wavelength in air. But what is wavelength in water upon wavelength in air? See here, refractive index of water is equal to wavelength in air upon wavelength in water. Therefore, wavelength in water upon wavelength in air is equal to 1 upon refractive index of water. So, therefore, theta angular width in water is equal to theta into, now wavelength in water upon wavelength in air, that is replaced by 1 upon refractive index of water. So, that is 0.20 degree divided into 1 upon 4 by 3. So, that is equal to 0.20 into 3 divided by 4, that is equal to 0.20 into 3 means it is 0.60 divided by 4. So, it is equal to 0.15 degree. So, the new angular width when the entire setup is deep in water is 0.15 degree. So, out of 4 options, option B is the correct option for this question. A parallel beam of monochromatic light falls normally on single narrow slit. The angular width of what? Central maximum in the resulting diffraction pattern. Now, the angular width of central maximum, what is the formula for angular width of central maxima, angular width of central maximum theta is equal to 2 times lambda divided by a, 2 times lambda divided by a. Now, as slit width increases, as a, that is slit width increases, what happens when slit width increases? And because theta is inversely proportional to slit width, angular width is inversely proportional to slit width, and when we say that slit width increases means A increases, what happens to the angular width? Then angular width theta decreases, angular width theta decreases. So, as far as this question is concerned, that the angular width of central maximum in the resulting diffraction pattern, angular width decreases when slit width increases. Look at the option C, angular width decreases with increase in slit width. So, C is the correct option.